All right, this is the first video where we're looking at some simulations on resistance. So in this simulation we've got a battery right here connected to some wires in a circuit, a red resistor, and then we've got a pinwheel here that's kind of spinning due to the flow of current or electrons through the circuit, and that's registering in amps right here on this dial. So I'm just going to kind of change and manipulate the conditions here in the simulation, and we're going to see kind of what the result is. Okay, so I'm going to increase the voltage here. So right now it's at 1.44 volts. So if I increase the voltage to, you know, close to 5 volts here, you can see now that these, you know, cranes that are carrying electrons from the positive terminal to the negative terminal have suddenly increased their involvement, their energy, and the heat in the circuit has increased somewhat as well. Okay, if I back it back up, you know, to where it was before, around 1.44, you can see the flow of electrons through the circuit has slowed down. The pinwheel is spinning kind of slow. The random motion in the resistor, as the atoms of the resistor are pushing on the electrons and resisting them, all that's kind of slowed down. As I increase it to 5 volts again, you can see here that the speed of motion through the circuit has increased. Our pinwheel is going faster, which means the current's going up, and that's actually registering as a greater ampage right here in the dial. And we got more of a, you know, random motion between the of the atoms or molecules that make up the resistor as the electrons are smashing into them, and that's what's actually causing a greater increase in temperature as a whole in our circuit and in our resistor. So if I increase the voltage again, let's go to 9.6, and again you can see current has gone up. The pinwheel's going faster. Our current is actually near 2 amps. The speed at which, you know, these cranes are bringing electrons from the positive terminal to the negative terminal, and that represents the chemical reactions inside the battery. That has increased. Our temperature of our resistor has gone up. It's warm now, again, because as the current has gone up, there's a greater collisions between the electrons and the molecules that make up the resistor, and they're bouncing around a little more randomly, and we're getting some heat. Now watch what happens when I increase the resistance of our resistor. So now what we're actually doing is we're increasing the more collisions between the molecules that make up the resistor, or the molecules that make up the resistor itself are actually pushing greater back on the electrons as the electrons try to move through the resistor. And you can see the current has gone down, the pinwheel is not spinning as fast, the flow of electrons through our circuit has slowed down, and we're getting you know, again, some random motion right there. So that just demonstrates as resistance goes up, then the flow of electrons is going down, because it's going to slow down because the flow of electrons through the circuit is decreasing. The particles that make up the resistor are pushing back on the electrons and resisting their flow through the circuit. Okay, so we'll see you in the second video when we look at another simulation for resistance.